So in today's session, we're going to talk about left hand and right hand limits. And that just basically means you're going to look on the left side of the limit. So anyway, I'll walk you through this. The left hand limit of f at x equals c is defined to be the value that the function f approaches as x approaches c from the left. Smaller values of x or less than values of x, right? So here we write the limit of f of x, the limit of f of x as x approaches c from the left. So let's practice writing that one out. The limit of f of x as x approaches c from the left. Okay, so the only thing that we're adding to from yesterday is this little minus sign up here. It says c, it almost looks like c to the negative power, right? So all that means is x approaches c from the left. Okay, so now you can kind of figure out what this c plus sign means. If it's c and it looks like it's being raised to the plus sign, it would be the limit of f of x as x approaches c from the right. C from the right. And we're about to find out why this is helpful to us. Okay, first off, just a review. Sometimes it won't have a plus or a minus. So what does that mean if it doesn't have a plus or a minus? Well, we eliminate the from the left and from the right altogether. And basically what it means is it approaches 7 from both sides. Okay, so we have to look at both sides. So on that example that we were doing, well, on this picture anyway, x is approaching 1, we'd have to look from the right and from the left. Okay, so let's scroll down further and take a look at this example. The graph at the right illustrates this point. The left-hand limit, written like this, the limit of f of x as x approaches 1 from the left, is equal to 1. You'll see here's x equals 1, right? So at x equals 0.2, 0.3, 0.4, 0.5, right? All the way up to x equals 0.9, it's getting closer and closer to what y value? It's getting closer and closer to the y value 1, and that's the number that we report. All right? This is true even though there's a hole at 1. It's saying what is the value tending towards, okay? So the value that the function intends to have is a 1. Okay, so now let's look at the right-hand limit. Here is x equals 1, but at x equals 2, we're way up here on this red piece of property, right? So let's go down to 1.5. Let's go down to 1.2. Let's go down to 1.1. Let's go even closer, 1.01, 1.001. And now we're getting infinitely close to what y value would we report there? 3. Okay, do you guys see how we got two different limits because we went to this from two different directions? Okay, so sometimes that happens. Okay, if that happens, we have a good vocabulary word for that, but we're just going to say that the limit itself does not exist. So if I said, what is the limit? Let's add this example on the right side. What if I just asked you this? What's the limit as x approaches 1? I should have said, what is the limit of f of x as x approaches 1? Well, it's two different answers, right? So if it's two different answers, then I just have to say that the answer for this problem does not exist. All right, and some people say is equal to does not exist, and that's okay. All right, so notice that there is a black dot on the point 1, 2, so that just means that the function value at 1 is 2. And that's nothing more, that shouldn't be too surprising, I guess. All right. So the function has a value at 1, but it's neither the left-hand limit nor the right-hand limit. This is because the function is not continuous at 1. So what do you guys think the word continuous means? This is the first time running into that word. Not continuous at 1. And basically, when you're given the picture, you guys can pretty much see what the word not continuous means, right? All right, so the word not continuous will imply, it might mean that the two limits are different, but let's look at this one up here. This one is also not continuous, but what do you think about the right-hand and left-hand limit? The right-hand and left-hand limit is both 2, right? So is that the definition of continuity? No. So in order to be continuous, to be continuous, yes, the limits have to equal each other, but this function value here also has to equal that limit value. I don't think we're ready for the strict definition of it right now, but I'm kind of alluding to what you'll need to know in the future. All right, so here we go. Does the limit exist? If the limit from the left, I'm reading that one as the limit of x, of f of x, as x approaches c from the left. All right, so that's the way I'm technically supposed to read it, but sometimes I'll just say, if the limit from the left equals the limit from the right, then the limit exists. So that the left-hand limit equals the right-hand limit, and that is the same thing as the limit. All right? So I'm not saying all the words that I need to say, but I'm saying it so that it'll be simpler to understand. Okay? So if the limit from the left does not equal the limit from the right, then the limit does not exist, as we said on the picture up there, right? So that means the limit is equal to undefined, or you could write d and e. And then it says in the previous example, does the limit exist? So we can answer this question. We can say no. The limit of f of x as x approaches what value? 1. As x approaches 1 from the left is not equal to the limit of f of x as x approaches 1 from the right. So the limit of f of x as x approaches 1, d and e, does not exist. So this is actually supposed to be one sentence, but I struggled to get it all on one line, I guess. Let's see if I can fix that. Wish you could do this with your magic paper, don't you? Sometimes. All right. Does that work? Okay, so let's go through a few pictures. Actually, I think this is a good time for you guys to stop and talk about this. And if you're just watching my video, then just pause the video and try these problems. Just going to get this filled in pretty quickly. We're going to go to -2 from the left. So that value is going to be -1. To from the right, that value is going to be 1. Notice that the answers are different, so we have does not exist. But we do have a function value at -2, and that is -1. All right, so the next problem then, 2 approaches +2 from the left. Well, that tends to be 1. This one from the right is 1. And then since those two answers are the same, we can put that answer down here. But then we have to go at 2. At 2, we have a closed dot right here, and that is 1. So all of these answers are the same. Okay? These answers are the same, meaning that the limit exists and the function is continuous. The limit exists and f of x is continuous at x equals 2. All right, so don't tell me that the limit is continuous because all of it equals 2, or I'm sorry, all of it equals 1. Tell me that it's continuous because they equal each other. You get what I'm saying? Tell me they're continuous because they equal each other, not because they equal 1. All right, so a couple of more examples I'll just walk through. And then, all right, so 2 from the right. I'm sorry, this says 2 from the left. So 2 from the left, we're going towards 5. And approaching 2 from the right, we're also going towards y equals 5. But the limit itself, does it exist? Yes, I tried to trick you there by using the word but, right? Okay, yes, those are the same, so that's 5. All right, so now is this thing continuous? That's what this last problem is about. F of 2, there's a closed dot right there, so f of 2 is actually just 2. So the limits exist here, or I'm sorry, the limit as x approaches 2 exists, but this is not continuous. Not continuous at x equals 2. Limit exists. So we're happy about that one. Okay, here's another challenge problem. I wanted to see if you guys could do it. Okay, so at which point does the limit not exist? Okay, I think there's one that definitely speaks to me, right? And it's loud and clear at x equals 2. So at which point it's at x equals 2. That's where the limit doesn't exist. Since the limit of f of x as x approaches 2 from the left does not equal the limit of f of x as x approaches 2 from the right. Okay? Now, if it asks specifically what those limits are, then you could say from the left it's 6 and from the right it's 2. 6 is not equal to 2. Okay? Show work that verifies that the limit does not exist at the values described in part A. Well, I think I just did that by accident. Okay, so see part A, and just did that. All right, there's another one though that you might have gotten stuck on and you weren't sure, and that might be at x equals 4. Does the limit exist there? What's the limit from the left? 4. And what's the limit from the right? Also 4. So actually the limit exists there. It's still not continuous, but the limit exists. And there's another one at x equals -4. That one's kind of interesting, right? Do you think the limit exists there?